In these problems, we're using something called a factor theorem, and there's nothing too earth-shattering about the factor theorem. What it basically says is that if something is a factor of a function, if you divide by that the function by that factor, you'll get 0 for a remainder. So what we can do here, they're asking which of the following is not a factor, which of these is not a factor here. What we can do is try some synthetic division and try them all out. See if you get a remainder or don't get a remainder. The first one where we get a remainder, boom, we've got our answer. So let's try this out. I'm going to set it up for synthetic division. 3, -5, -59, 41, and 20. The first one is -5. So when we do x minus 5, so when we divide, we'll be dividing by 5 here, +5. So let's give that a shot. 3 times 5 is 15, so we've got 10 there. There's 30. Whoops, 50. So that's -9. That would be -45. So we've got -4 here, and that's a -20. So that one is a factor. We didn't find our answer because remember we're looking for one that's not a factor. So let's set it up again. 3, -5, -59, 41, and 20. And let's see. Looking at these other factors, we have -1/3. We have +1/3. I'm just solving here for the actual 0. And then a -4. And to save time and space here, I'm going to go ahead and jump right to the one that's not the factor, because I went ahead and tried this out ahead of time and show you that it's not. The others, if you plug them in the same way, you'll come up with zeros for remainders, and you'll know that they are factors. But I'm going to try 1/3 here and see what happens. So bring the 3 down. Times 1/3 is 1. So that's -4. So that's -4/3 here. And let's see. So this would be -181/3. Whoops. So times 1/3, that's going to be -181/9. 188/9. Multiply that by 3. Sorry, multiply that by 1/3. We get 188/27. And you can see they're both positive numbers here, so we're going to end up with a remainder there. And I think that's 728/27. So that one has a remainder, so this is not a factor, which would mean 3x. This is not a solution, so it means 3x plus 1 is not a factor. Let's look at one more. Same business here. It says use the factor theorem to determine how many of the following are factors. And you're going to do the same thing. Set up your synthetic division and test each one of these. 1, 2, 3, 4, 5, 6, 7. So you've got 7 to test there. So as you can see, these problems are quite a lot of work. But we'll do just a couple here to get you started on your way, and we'll let you do the rest of them. So setting this up for synthetic division, we get 3, -11, -55, 163, and 60. Numbers don't look terribly nice either, do they? And let's try x minus 3 first, so that would be a +3 out here. So 3 times 3 is 9, that's a -2, so -6 here, so -61, and let's -183, so this would be -20 down here, and -60, we get a 0 for a remainder, so x minus 3 is definitely a factor. Let's do another one. Let's do the next one. So the next one is x minus 4. So we'll set it up again. And let's see, x minus 4, so this will be a +4 out here. So 3 times 4 is 12, that's 1 times 4, and that's -51 times 4 is -204. Let's see, that's -41. You can see this one's not going to work out, so 4 times -41, that's -84. So you actually get -24 here. So since there is a remainder, x minus 4 is not a factor. And then you simply work your way through the list, testing all of these. So that's a little bit about using the factor theorem.